Welcome back, everybody. We're going to go through our Chapter 3 test review today. For any questions that you might have, and hopefully seeing these work through will help as you're getting ready to take your test and you're studying. Numbers 1 and 2 are talking about if these relations are a function or not. As I'm looking at number 1, I see a -2 and a -2 in the x's. And so, no, this is not a function because x values are repeated. For number 2, checking out our x values here, none of them repeat, so yes, no x values repeat. Or there is exactly one output, unique output for every input. Three through 6 is asking whether these are linear functions or nonlinear functions. So if we're talking about linear and nonlinear functions, it's kind of asking us, is there a straight line that we can graph from it? Does it have a constant rate of change? Can it be written in y equals mx plus b form? So for number 3, I'm going to get y alone. Remember, the two steps that always work for getting y alone is to add or subtract x to the other side. 7y. Remember, we can't add 14 and 4x. They're not like terms. So we will just have them sit next to each other. From there, we divide everything by 7. And we get y is equal to 2 plus 4/7 x. So we could say, yes, this is linear because we can write this in y equals mx plus b form. Or we can say it'll have a constant rate of change. Or you could graph it to show that this is going to be a straight line. For number 4, is this function a linear function? And I'm looking at that x squared saying, okay, y equals mx plus b is x to the first power, that's x squared. So no, we cannot write in y equals mx plus b form. X equals -3. This is going to be a nonlinear function. If I were to graph this, x is -3 right here. It is a vertical line. So it is nonlinear because it is a vertical line. That's part of the definition of a linear function. And it cannot be written in y equals mx plus b form. For number 6, let's see if we can get y alone here. Divide by 4, divide by 4, divide by 4. We get y is equal to 7/4 x minus 1/4. And so, yes, this is linear because we wrote this in y equals mx plus b form. Seven and 8 are asking about domain, range, and if they are discrete or continuous. So domain, remember, are x values. When I have dots like this, I'm just writing a list of what those x values are. So I see 2, 3, 4, 5, and 6. 2, 3, 4, 5, 6. Range is y values. And so the y values are 2, 3, and 4. This domain is discrete because it's a set of dots. They aren't connected together. So that means we can only have those values. We can't have any other values. For number 8, these two dots are connected. That means that we can have any x values in between this right here, which is -3, and this side, which is +2. So we could have -2.795. We can have 0.332. We can have 1.4. We can have those decimals. And so for domain, x values, our lowest x value is -3, and our highest x value is 2. For our range is y values, so our lowest y value is here at -3, and our highest y value is up there at +1. So -3 is less than or equal to y is less than or equal to 1. Because we've connected these dots with a line, and we can have bits and pieces of x, 1.42, -0.5, things like that, that makes this a continuous domain. For number 9, we have a function named r. Here, they're asking us to change our x to -1. So that means we change that x to -1. 3 times -1 minus 6. 3 times -1 is -3. -3 minus 6 more, or if we add the opposite, it would be -3 plus -6, makes that -9. For 10, we're changing x to 8. So we change that x to 8. 3 times 8 minus 6. 3 times 8 is 24. 24 minus 6 is 18. So our answer there is 18. Number 11 is telling us that this whole part, r of x, is 12. Find what x is. So we're changing r of x to 12. Solve for x. I'm going to add 6 to its like term. That's 18. 3x, and that adds to 0. The opposite of multiplying by 3 is dividing by 3. So I divide both sides by 3. 18 divided by 3 means that x is equal to 6. (12) and 13 are asking us to describe what the answer they give us means. So in number 12, we're talking about the height of a ball in feet, a certain amount of time in seconds after it was thrown. So since the time in seconds is what's in the parentheses, then it says that means after 5 seconds, the 65 is the height. The ball is 65 feet, and I got feet from this right here. And I can put off the ground or high, or it reached a height of 65 feet after 5 seconds, however it is that you want to say that. So for 13, we have R is the rent paid in dollars, M months after it was rented. So since M is in the parentheses, the 16 in the parentheses is M. So after 16 months, we have paid $16,000. And notice I put the dollars here because it's saying that that unit is dollars. $14 and $15, we're talking about using the graphs to find the values. Find the value of x so that the answer is -3. Remember, f of x is the same as y. And so they're telling us y is equal to 3. Where is y equal to 3? Y is equal to 3 right here. There's where it matches up on our graph of f. The x value there is 2. So if I asked you to find x so that f of x is equal to -1. Well, f of x is equal to -1 means y is -1. So here is where y is -1. That's also where it hits the graph, and that x value there is 0. For 15, it's saying find f of 2. So remember, that was f of x. X changed to 2. So where is x2? X is 2 right here. This is also where the line is graphed. So what y value is that? That y value is 0. So if I asked you for f of 1, that means find where x is 1. I'm going to change color here. X is 1 right here. There's where it touches the graph of f, and that y value is 3. $16 and $17 are asking about x and y intercepts. So remember, x-intercepts are when we plug 0 in for y and solve for x. So 2 times 0 is 0. We can add 0 to the other side, but remember 0 really is just nothing. It doesn't change anything, so you could also drop the 0. And the last step, the opposite of multiplying x by 5 is dividing x by 5. And so we get x is equal to 2. So 2, 0 is our x-intercept. For the y-intercept, we plug 0 in for x. 5 times 0 is 0. This 0 doesn't affect our -2y, so we can drop that, or we can move it to the other side like we did here for x. It just depends on what makes the most sense to you. The opposite of multiplying y by -2 is dividing y by -2, and so we get y is equal to -5. For 17, our x-intercept, we have 2/3 x plus 3 times 0 is equal to 6. 3 times 0 is 0. Anything plus 0 is itself. So we can look at this as 2 divided by 3. The opposite of dividing by 3 is multiplying by 3 on both sides. These reduce to 1s, so I'm left with 2x. 6 times 3 is 18. The opposite of multiplying by 2 is dividing by 2. So 18 divided by 2 is 9. That makes our x-intercept 9, 0. The y-intercept, plugging 0 in for x. Two-thirds times 0 is 0. 0 plus 3y is 3y. 3 times y, the opposite is dividing by 3. 6 divided by 3 means that y is equal to 2. (18 to 21) are asking us to find slope. We have slope formula here. And so finding slope, we can use slope formula for all 4 of these. We can also find slope just by using our rate of change if we're given a list of values like we are in 18. So our rate of change in 18, 5 to 2 to -1 to -4 is a change of -3 each time. -3 to 2 to 7 to 12, we're adding 5 each time. Remember that slope is y over x. If we refer to that right there, it's y over x. So our y change is 5 and our x change is -3. That makes the slope for this -5/3. For 19, we have ordered pairs. So I'm going to go ahead and label x1, y1, x2, y2, and I'll plug it into this formula. So we have y2, which is 10, minus y1 is -2. Note that I have the subtraction from the formula and then also the negative from the 2 being negative. x2 is -3 minus x1 is -3. Minus negative, add the opposite, becomes adding. 10 plus 2 is 12. Minus negative becomes adding. -3 plus 3 is 0. Well, we cannot have 0 in the denominator of a fraction, so this is undefined or no slope. If I take a look at number 20, and again, I have ordered pairs, so I'm going to label them just to help me put them in the formula a little bit easier. So I labeled y2 is 6 minus y1 is -2. x2 is -4 minus x1 is 6. If we add the opposite, 6 plus 2 is 8. Add the opposite, -4 plus -6 is -10. So we have -8 over 10, and we always want our fractions to be in simplest form, so that would reduce to -4/5 for our slope. For number 9, I'm going to switch this up a little bit, and I'm going to make this first one x2, y2, and the second set x1, y1, because remember, that part doesn't matter. What matters is that you're consistent. So slope, we have y2 is 4 minus y1 is 4. x2 is 9 minus x1 is 17. 4 minus 4 is 0. 9 minus 17 is -8. And 0 divided by anything is 0. So this is zero slope. And remember, zero slope and no slope are two very different things. And we can see actually right here why that is. This was 12 over 0, and this was 0 over 8. It has to do with where that 0 is. Graphing the linear equation using any method you want. Let's see, for 22, I think I'm going to use intercepts. So if I use intercepts for that, I've got, let's see, x-intercept would be x plus 4 times 0 equals 8. 4 times 0 is 0. X plus 0 is x. So our x-intercept is at positive 8. So I'm going to plot that here. The y-intercept, we plug 0 in for x. So 0 plus 4y is equal to 8. 0 plus 4y is 4y. And then divide by 4 to get y is equal to 2. And then we connect those dots. And there's the graph of our line. For 23, this is in slope-intercept form, and I know that because y is alone. So that means that my slope, the value that's attached to x, is negative 3/2, and my y-intercept, or my b value, is 7. So I'm going to go up to positive 7, and then slope, down 3, 1, 2, 3, right 2, down 3, right 2, down 3, right 2. There's my 4 good points. Connect those dots. Number 4, this is also already in slope-intercept form. And again, we know that because the y is alone. So our slope is 2, and if I wanted to make that rise over run, I'd put that 2 over 1, and my y-intercept, or my b value, is negative 5. We start at negative 5, plot that point, and then from that point, rise 2, run 1, rise 2, run 1, rise 2, run 1. And there's our graph. And number 25, this is also already in slope-intercept form because, again, y is alone. So in front of the x there, that's a negative, but it's a negative 1. So my slope is negative 1, making that rise over run would be negative 1 over 1. And my y-intercept, or b value, is 1. So if I start at 1, then we go down 1, right 1, down 1, right 1, down 1, right 1. And there's our graph. Vocabulary. Make sure that you've reviewed your vocabulary for the chapter. Anything is possible to be addressed or asked, but it will be in this format where whatever vocabulary is listed, you would be able to choose the word and then write the definition. You know, our tests always have review questions, so we have an OR problem here to review. Now remember, OR means you have to solve both of these. And then when we're done, we put them back. If we were to graph this, we would graph them on the same line. But I drew this squiggly here to show I've got to solve the left side, and then when I'm done, solve the right side. Solving the left side for x, I would start with subtracting 3 to the other side with its like term. 3 minus 3 is 0. We subtracted, we did not divide. So the inequality stays the same. 15 minus 3 is 12. The opposite of multiplying x by negative 3 is dividing x by negative 3. These reduce to 1x. We did divide by a negative, so remember that changes our inequality to the opposite direction. And then 12 divided by negative 3 is negative 4. I'm going to put my or back there. And then on this right side, the opposite of multiplying x by 2 is dividing x by 2. Now we're dividing by positive 2, so nothing happens to our inequality. It stays the same. 2 over 2 simplifies to 1, and 8 divided by 2 is 4. 29. I need to start with distributing. So negative 2 times 3x is negative 6x. Negative 2 times negative 1 is positive 2. I'm going to go ahead and move my x values together. This over here is a positive 6, so the opposite is to subtract 6x. Remember, when we're combining like terms, we always either add or subtract. Now, negative 6 minus 6 more is also like saying plus negative 6. So we owe 6 to another person, we owe a total of 12. So that's negative 12x plus 2. We subtracted. Subtraction does not change the direction of our inequality. These add to 0, and we have 10. I will subtract the 2 to the other side for that like term. We have negative 12x. This adds to 0. We subtracted, so that does not change our inequality direction. And 10 minus 2 is 8. Then the opposite of dividing by, or multiplying by negative 12, is dividing by negative 12. That reduces that to positive 1x. We did divide by a negative, so our inequality changes direction. We can't divide 8 by negative 12 evenly, but we can reduce that by 4. And so that makes that negative 2/3. And that would be our answer. All right, going back to the beginning and reviewing some more, we're talking about, is this a function, yes or no? And remember, we're looking for the fact that every output is unique to an input. In other words, x values are not repeating. So if I look at my x values here, I have 0, 5, and 7. So yes, this is a function because no x values repeat. For number 2, when we're given a graph, we can do the vertical line test. And we can see that, we do several of these and we're touching the graph in more than one spot. So this is not a function because it does not pass the vertical line test, VLT, vertical line test. For number 3, we're looking again just at the inputs, and as long as there's only one line coming from each of those values, then yes, it is a function. No x values repeat. All right, number 4. Independent and dependent variables. All right, so we have our function about babysitting for X hours, and Y is the money in your bank account. Remember, the independent variable is X values. And so we're looking for what does the dependent variable depend on. So the question then is, does the amount of money in your bank account depend on the hours you babysit, or does the hours you babysit depend on the amount of money you have in your account? In this case, for this function, the money in your account depends on the hours you babysit. So as soon as you say depends on, that means that is the dependent variable. And so our dependent variable is money in the account. That makes the hours that you babysit the independent variable, because you can choose how many hours you babysit. And then however much you get in your bank account and will depend on how much they pay you for your time. This is where we're going to stop for today. If you have any questions, don't hesitate to reach out. Thank you so much. We'll see you soon.